Hey and welcome to this week's video. Have you ever wondered about setting up efficient tests for your Kotlin Multiplatform project? Or wonder how to ensure your code is well covered and reliable across different platforms? If so, you come to the right place. My name is Per-Erik, and on this channel we deep dive into different Kotlin Multiplatform topics, and today we are tackling the crucial topic of testing. If you're new to Kotlin Multiplatform, don't worry, this video will serve as a brief introduction to get you started with testing. We walk through everything you need to know, from adding the dependencies to setting up the test coverage report, ensuring your code is rock solid across all the platforms. And stay tuned, because by the end of this video, you will have a clear roadmap to set up and running your test in a Kotlin Multiplatform project, giving you the confidence to dive deeper into this new technology. Let's get started. So the first thing we need to do is add the necessary dependencies. Most of these dependencies are already part of the version catalog, but we still need to declare them inside the Gradle build file. So to add them, we need to have a new source set called common test. Here we can add all the dependencies we need for our test. For now, we're just going to add the Kotlin test. Let's break down what Kotlin test includes, because it's a group of libraries that will be included. The first one is the Kotlin test itself. It's the core Kotlin testing libraries, which include common test assertion and utility. It provides the basic functionality you need to write and run your tests. Then you have the Kotlin test JUnit. These add JUnit integration for Kotlin tests, providing the compatibility with JUnit 4. It allows you to run your tests using the JUnit framework. Then we have the Kotlin test common. These provide common test annotation and utilities that are platform independent. It ensures that your test code can be shared across the different platforms. And finally, we have the test annotation common. These provide the common test annotations like test, before test, and after test, which can be used across all the platform. There is also one more thing we need to do. We need to add instrumentation runner for Android. So let's go down to the Android block under the default configuration and add the Android JUnit runner. We also need to create the folder structure for our test. So let's create the source folder called common test. Under common test, we add the Kotlin. This is where we put all the tests we will write. For example, we can create a file named mytest to verify our setup. Yeah, and don't forget to sync the project after adding dependencies or any change in the Gradle build configuration. I often overlook this myself. But as soon as the synchronization is done, now let's add a simple test function to ensure that everything is working. We'll create a test that initially fails by asserting false. We use the test annotation to mark this function as a test function. Then we run it. The test should fail as expected. Then we change to assertion to true and run the test again, which now should pass. Next, let's talk about test coverage. We want to see how well our tests are covering the code. For this, we use the cover plugin to set it up, add the plugin, and configure it in the build script. To configure it, we create a cover block, and here we can specify the reports we want. Let's add a verify block and then add the rules we need. In this case, we are setting a minimum coverage of 80%. Now, when we run the cover verify task, it will check our coverage. If it fails, we can then generate an HTML report and look at that and see what is missing. You run the report by triggering the task cover HTML report. The report provides a detailed view of our coverage, showing us which packages and files need more testing. We can also see here that there are many things we cannot or don't want to test. We can include those from the report. We exclude things in the cover block under the reporting by adding a new block called filters. In this block, we will filter out the things that we don't want to cover in the report. The first thing that I would add would be the entry classes, since nothing much will happen here anyway. I would also exclude generated code, so I'm excluding those packages as well. Remember that different libraries generate different things. You might need to adjust these as the project goes. I also don't think there is any idea to testing the dependency injection package, especially if you're using a frame role like I'm doing here, Coin. I trust that they did the testing for me on their side. For this video, I will also exclude the composable files because I'm not doing any UI testing. Now, if we run the cover report, we can see that the report is much more cleaner and we can more easily see where we need to create tests for. One important thing to remember is to not exclude files just to reach 80% coverage goal. Imagine that you have 100 lines of code and you exclude 10% of them. That means that you only need to cover 72 lines to achieve 80%. But this is kind of misleading because you're actually only covering 72%. I'm not saying that you should never exclude code. Sometimes it's necessary, especially if the code is very hard to test. However, code that is very hard to test might be an indication of code smell or a technical debt that you should address. Just to be mindful and ensure that exclusions are justified. The goal is to have meaningful and accurate test coverage that truly reflects the reliability of your code. Now, let's look at our coverage. We can see that there's a lot of red lines, meaning that we have low coverage. So let's start writing some tests to get our coverage up. When writing tests, it's helpful to follow a structured approach to ensure clarity and efficiency. One widely adopted method is the AAA pattern, which stands for arrange, act, and assert. Arrange is the first part of the test. This is where you set up the conditions for your test. You instantiate the object and set up the preconditions. Essentially, you are preparing the environment for the test. Act is the step you perform the action that you want to test. This is the execution phase where you invoke the method or the process that you are testing. Assert, the final part. This is where you verify that the outcome of the action matches your expectations. You compare the actual result with the expected result to determine if the test passes or fails. Let's start by creating our test file in the test folder. The first test is very simple. We just check if the addition function returns the correct result. We can do this with a simple assertEquals function. We can run the report and see that we now have some green lines, indicating that these lines are covered by tests. Let's move on to the next test. We will test if adding two floats also work. With floats, there is a little bit issue with the float precision, so we can't just use assert the same way we did with the integers. We also need to add a tolerance level. Let's also add a test for a function that doesn't return anything, but to change a state, and then let's run the report and see how it looks like. Not surprising, but we have more green lines. If we run the cover verify, we can still see that we are failing, so let's continue adding some tests. And of course, we can see the coverage in the report as well. Let's continue. The next test is for a suspend function, a function that will return a flow and a function that will update a state flow. To do this, we need to add one more dependency in the Gradle build file. We need to add the coroutine test library. We add these in the common test block. And remember, synchronize the project. For the suspension function, we use the run blocking function. Here we notice that Fleet is a little bit in preview mode only so far. Sometimes we actually manually have to add the imports. But I'm sure they will fix those issues soon enough. Now, for the function returning a flow, here we will also use the run blocking function. We convert the flow to a list and use the assertContent function to check that we get the expected array back. And finally, we will test the functions that are updating a state flow. For this, we need help of some objects. We first need a test dispatcher, and we also need a test scope. For this, we will need to set up the before test function and an after test function. This last function that we will test, I will show two different ways to test it. The first we will do using the test scope that we set up using async and await. We will also add the advanced by time function to speed up the test. And the second approach, we will use the run test function without the async await. Here we need to make sure that we use the advanced by time before we are fetching the value. Now, if we run the cover verify function, we get the success. Great. And if we generate the report and check the coverage, we now see that everything is green and we are good to go. Thank you for watching, and don't forget to hit like and subscribe, and I'll see you in the next video.